Hey, it's Mr. Estrada here, and in this video we are going to go over each question in the January 2013 Geometry Regents. So let's get to it. Here's number one. It says, if triangle MNP is congruent to triangle VWX and PM is the shortest side of triangle MNP, what is the shortest side of triangle VWX? So this question is basically asking you to think about the corresponding parts of congruent triangles. So it's asking you to think about the CP/CTC properties. So if PM is the shortest side on triangle M and P, then it follows that the corresponding side on triangle VWX should be the shortest side of triangle VWX. So then that would be side XV. So the answer to number one is choice one. So to summarize, PM corresponds to XV. So since PM is the shortest side in triangle MNP, then XV should be the shortest side in triangle VWX. Here's number two. It says in circle O shown in the diagram below, chords AB and CD are parallel. If the measure of arc AB is 104 and the measure of arc CD equals 168 degrees, what is the measure of arc BD? So we are told that arc AB is 104 degrees. So I'm going to go ahead and just label that 104 degrees. We are told that arc CD is 168 degrees. So that means this arc here measures 168 degrees. Now, of course, the whole circle is 360 degrees. So to find the measure of arc BD, we have to keep in mind the theorem that says that parallel chords intercept congruent arcs. Parallel chords intercept congruent arcs, and all that simply means is that this arc here will be equal to this arc here since these two chords are parallel. So we know that these two arcs must be the same. So if we add up 104 and 168, we will get 272. 360 take away 272 is what? That will be 60 plus 28, so that's 78. Sorry, 88, so that's 88. And what that means is that these two arcs must add up to 88 degrees. They must add up to 88 degrees. And since they're both equal, we can take the 88 divided by 2, and we will get 44, and that will be the measure of each one. So 44 and 44. So the answer to number 2 is choice 2. And one way that you can check that this is right, if you add up the measurement of each one of these arcs, you should get 360 degrees, and you do if you go ahead and take the time to do that. Okay, so number 3 says, as shown in the diagram below, CD is a median of triangle ABC. Which statement is always true? So all that we are told here is that CD is a median of the triangle. And I wrote this down for you. A median connects a vertex and the midpoint on the opposite side. So we know that point D is a midpoint of AB. Therefore, we know with certainty that AD is congruent to DB. And so the answer is choice 1. Number 4, in the diagram below, under which transformation is triangle A prime, B prime, C prime the image of triangle ABC? So in a dilation with a scale factor of 2, the figure is supposed to get bigger, and that did not happen, so it cannot be choice 1. Choice 4 is showing us a translation. You're supposed to have a slide, and the orientation is supposed to be preserved. So we know it's not choice 4 because we don't have a slide, and the orientation is not preserved because we have a different ordering of the points. So it's either a reflection across the x-axis or a reflection across the y-axis. And if we look at the original image, it's right over here, and you can see that point C is reflected across the y-axis and ends up here. Point B is reflected across the y-axis and ends up here. Point A is reflected across the y-axis and ends up here. So the answer is choice 3, reflection across the y-axis. Also, another way to think about it, a reflection in the y-axis, what that does is it takes the original coordinates and changes the sign of the original x-coordinate. It negates the x-coordinate, and that's exactly what happened here. Number 5 says line segment AB is a diameter of circle O whose center has coordinates 6, 8. What are the coordinates of point B if the coordinates of point A are 4, 2? So let's go ahead and give ourselves a picture just to sketch this out a little bit. So it says line segment AB is a diameter. So that means we have a circle and we have a line segment that's a diameter. So that means it cuts the circle right in half. So this is line segment AB. And it says that it has a center that has coordinates 6, 8. And then it says what are the coordinates of B? So they want the coordinates of point B if the coordinates of point A are 4, 2. So the coordinates of A are 4, 2. So what we can do to find point B is we can find the change in the x coordinates and the change in the y coordinates, and then we will apply that same change to the midpoint because this is a midpoint, it's at the center of the circle. We will apply that change to the midpoint to get the next point. So that's what we'll do. So let's go ahead and analyze. So point A has coordinates of 4, 2. The center has coordinates of 6, 8. So what's the pattern to go from 4 to 6? You know, what's the change? So they added 2. And then to go from 2 to 8, they added 6. So we will do the same thing to get the coordinates of point B. So 6 plus 2 is 8, and 8 plus 6 is 14. So we get 8, 14. So the answer to number 5 is choice 3. Okay, number 6 says plane A and plane B are two distinct planes that are both perpendicular to line L. Which statement about planes A and B is true? So they are two distinct planes. They are two different planes. So we've got plane A and we've got plane B. And the reason why I'm drawing them like this is because it says that you have a line L that's perpendicular to both of these planes. So this line is perpendicular to both of these planes. That's supposed to be a right angle box. Another way you could think about this, think of this as a ceiling. Think of it as a ceiling, and then think of this as a floor. And then this is just like a column. Line L is just a column that's holding the ceiling up and is attached to the floor. Right? So you know that that column has to be perpendicular to the floor. So obviously if this is a ceiling and a floor, they're not going to have a common edge. The planes are not perpendicular to each other. In fact, they are parallel to each other. So the answer is choice 4. And choice 3 is out of the question because obviously a ceiling and a floor will not intersect each other. So that doesn't make sense. So the answer is choice 4. Number 7 says triangle ABC is similar to triangle DEF. The lengths of the sides of triangle ABC are 5, 8, and 11. What is the length of the shortest side of triangle DEF if its perimeter is 60? So let's draw this out. So we got a triangle ABC. This is of course not drawn to scale. And it has sides of 5, 8, and 11. And then the perimeter of this triangle will be 8 plus 5 is 13. 13 plus 11 is 24. So the perimeter of this triangle is 24. So the other triangle, we know it's going to be bigger because it's got a larger perimeter. The perimeter of it is 60. And what they want is they want us to find the shortest side of this triangle. So now you will recall that in similar figures, the sides are proportional. So that would mean, that would actually imply that the perimeters are also proportional. So we can create a proportion, and I'll do it this way. I can do 5 over 24 equals x over 60 to find that missing side. So 5 over 24 equals x over 60. So what you will do is some cross multiplication. You'll get 24x here equals 60 times 5. That's going to be 300. And then we're going to divide both sides by 24. And we will get x equals 12.5. So the answer is choice 2. Number 8. Number 8 says in the triangle below. Number 8 says in the diagram below of right triangle ABC, altitude CD is drawn to hypotenuse AB. If AD equals 3 and DB equals 12, what is the length of altitude CD? So I'll label this X since that is the unknown. I'm looking for that. And I'll begin this problem by stating the following. These are 3 triangles that we have here. Triangle ADC, triangle CDB, and triangle ACD. So we got 3 triangles here, all right? And they're all overlapping. And the other thing that I need to say about these 3 triangles is that they are all similar to each other. So what I will do is I will actually draw 2 triangles for you. And I'm going to rotate one of them so that the sides line up the way they're supposed to. So let's take this triangle here, triangle ADC. And I'll just go ahead and draw it like that. That's triangle ADC. This is 3 and this is X. Now triangle CDB is similar to this triangle. What I will do though is I will rotate this triangle 90 degrees counterclockwise. I'll rotate it 90 degrees counterclockwise so that the sides line up the way they're supposed to. So I get triangle CDB like that. And this is X and this is 12. That's a D. So now from this I can make a proportion to solve for X. And I will get X over 3 equals 12 over X. So you get 12 times 3 equals 36. X times X equals X squared. You'll have to square root both sides. So the answer is choice 1. Number 9 says, the diagram below shows the construction of an equilateral triangle. Which statement justifies this construction? So when you go through a construction like this, specifically this one, to make an equilateral triangle, what you are actually doing is you are constructing 3 equal sides. So usually you begin with one line segment. In this case, you begin with segment AB. And you'll swing an arc this way, and then you'll flip the compass around, swing an arc. So why don't I just show you? So the way that the construction is done, you begin with a segment. Let's call it segment AB. Segment AB. All right, so you begin with a segment, and you will swing an arc like so. You'll keep the compass setting the same. Put it on point B this time, and swing an arc like so. And then you will connect from point A to the point of intersection, and then from point B to the point of intersection. I didn't do such a good job of connecting to the point of intersection. Let me fix that up a little bit. So what this construction just did, it created 3 equal line segments. So you started with segment AB, but then what you did is you created 2 other line segments that are equal to AB. So the answer is choice 3. What is the slope of the line perpendicular to the line represented by the equation 2x plus 4y equals 12? So we have the line here, 2x plus 4y equals 12, which of course is not in standard form, so we'll have to put it in standard form. What do I mean by standard form? Y equals mx plus b. So let's go ahead and do that. Subtract 2x from both sides. We get 4y equals negative 2x plus 12. We'll divide both sides of the equation by 4. And we get y equals negative 1/2 x, because 2 over 4 reduces to 1/2. And then 12 over 4 reduces to 3, right? So this is the equation of the original line. Now, let's go back to the question. So what's the slope of a line perpendicular to this? Well, the slope of this line is negative 1/2. A line that's perpendicular to this, well, the slope of that line, that says slope of the perpendicular, must be the negative reciprocal of negative 1/2. What's the negative reciprocal of negative 1/2? It's 2 over 1, or just 2. So the answer is choice 2. Number 11 says triangle ABC is shown in the diagram below. If DE joins the midpoints of ADC and AEB, which statement is not true? So here we got ourselves a nice mid-segment question. And a mid-segment is half of the opposite parallel side. So segment DE is a mid-segment because it connects 2 midpoints of a triangle. We are told that D and E are midpoints, so that makes it a mid-segment. So we know that segment DE is half of the opposite parallel side. So automatically choice 1 is true because it says DE is half of CB. Choice 2 is also true. DE is parallel to CB. It's just a definition of the mid-segment. Let's jump to choice 4. Choice 4 says triangle ABC is similar to triangle AED. That is also true. The mid-segment will create 2 similar triangles. In this case, triangle ABC, that's the whole thing, is similar to the smaller triangle you see here, AED. And then for choice 3, that proportion that they give is not true. So the answer is choice 3 because they're asking for what's not. Number 12 says the equations x squared plus y squared equals 25 and y equals 5 are graphed on a set of axes. What is the solution of this system? So if we go ahead and graph this, we will get a circle So that first equation is going to produce a circle on the graph, and then the second equation will produce a line. So let me just go ahead and graph this circle and line. So it's going to be a circle with a center at the origin, and the radius of this circle will be 5. You got to square root the 25 and you get the radius. And then the line, it will be a horizontal line like this, going through 5 on the y-axis. So then it says, what's the solution of the system? And of course the solution is at the point of intersection. In this case it's 0, 5. So the answer is choice 3. Number 13 says square ABCD has vertices A, B, C, and D. What is the length of a side of the square? So to answer this question, we will have to use the distance formula. So we're going to have to find the distance of one of the sides of the square. Of course, all the sides are equal in a square, so just finding the length of one side is enough. Now, make sure that when you find the length, you actually find the length of a side and not a diagonal. So if you were to just draw in a square ABCD, you have to remember that the vertices have to go either in clockwise or counterclockwise order. I know that doesn't look like a square, and I know that it's not on a graph. It's not necessary. The only reason why I'm doing this is because I want to show you that if you're going to find the length of a side, it could be any of these 4 sides, AB, BC, CD, and AD. Make sure you don't make the mistake of finding the length of a diagonal. Alright, so I'm just going to go ahead and use a distance formula to find the length of AB. This is what you will have after plugging into the formula. And let's go ahead and do some arithmetic. 4 minus -2 will give us 6, so we get 6 squared plus, then -1 minus -3, that's going to be 2. So we get 6 squared plus 2 squared, that will be 36 plus 4. 36 plus 4 is 40, so we get radical 40, and then we can use the perfect square 4 to factor it, so we get radical 4 times radical 10, that's 2 radical 10, so the answer is choice 2. Number 14, it says in number 14, the diagram below shows triangle ABD with ray ABC. BE is perpendicular to AD, and angle EBD is congruent to angle CBD. If the measure of angle ABE is 52, what is the measure of angle D? So let's go ahead and label some of the stuff we're given here. So we're told that angle ABD, excuse me, not ABD, angle EBD, this angle here, is congruent to angle CBD. So these two angles are equal to each other. We're also told that B is perpendicular to AD, and we see that here it's already marked for us, that 90-degree angle. Then it says the measure of angle ABE is 52, so this is 52 degrees. What is the measure of angle D? So question mark for angle D. Okay, so well, what do we know about this triangle here, triangle DEB? Well, we know that this angle here must also be 90, because we have ourselves a linear pair here. These two have to add up to 180. Now, these angles here are supplementary, and they must also add up to 180 degrees. So these two missing angles plus that 52 must equal 80 degrees. So if I go ahead and just call these x and x, we get 2x plus 52 equals 180 degrees. And if I go ahead and solve for x, I will get the following. Subtract 52 on both sides. 180, take away 52 is going to be 128. Then I'm going to divide both sides by 2. and I get x equals, what's that gonna be, 64. So that means these are 64 apiece. So they're both 64 degrees. And let's go ahead and check that. 64 plus 64 is 120. That's 128. 128 plus 52 is 180. So we know we're good. Okay, now let's go back to this triangle that we were focusing on earlier. Talking about this guy here. Well, we know two of the angles are 64 and 90. Right? We knew that this over here was 90 degrees. So that means 90 plus 54, sorry, not 54, excuse me, that's 64. We know 90 plus 64 plus angle D has to add up to 180 degrees. So 90 plus 64 is 154. So we get 154 plus angle D equals 180. We're going to subtract 154 from both sides, and we get angle D is equal to 26 degrees. So the answer for this is choice 1, 26. Number 15, as shown in the diagram below, FD and CB intersect at point A, and ET is perpendicular to both FD and CB at A. Which statement is not true? So think about it. I like to think about this question in this way, right? I like to think of this as a lid, you know, like a lid on a cup. You know, when you get your iced coffee, they put this thing on top, right? A lid. And then think of this ET as a straw. So you got yourself a lid, and then you got yourself a little straw, right? Some type of straw that goes right through a point on the lid. So that's the situation we have here, okay? You got a lid and you got a straw going through the hole in the middle, and that straw is perpendicular to the lid. So it says, which statement is not true? So it says ET is perpendicular to plane BAD. Yeah, well, that's true, because we were told that ET is perpendicular to those two lines, so that means it's perpendicular to the lid. That's what it's saying, and that's true. Then it says ET is perpendicular to plane FAB. Again, same thing. They're referring to the same plane, just by a different name, so that's also true. Choice 3 says ET is perpendicular, again, same thing. The straw is perpendicular to the lid. And then choice 4 says ET is perpendicular to plane BAT. If you look at plane BAT, that's this guy over here, that line ET is contained in that plane. So it wouldn't make sense for that line ET to be perpendicular to that plane. So we know this is not. Number 16 says, which set of numbers could not represent the lengths of the sides of a right triangle? So for number 16, and these types of questions, in order for a set of numbers to represent the lengths of the sides of a right triangle, those numbers must satisfy the Pythagorean theorem. And the Pythagorean theorem says a squared plus b squared equals c squared. So what you want to do is you want to work through each one of the choices until you find the one that does not represent the lengths of the sides of a right triangle. So why don't we begin with choice 1. So I'll write 1 here to represent choice 1, and I'll plug this into the Pythagorean theorem, and I'll see if it satisfies it. So when I plug it in, the first number will be the A, so I get 1 squared, plus the second number will be the B, so 1 squared plus 3 squared, and the last number will be the C, so that will be radical 10 squared. So 1 squared is 1, 3 squared is 9, and then radical 10 squared is just 10, so I get 10 equals 10. So the Pythagorean theorem is satisfied for the first choice. For choice 2, I'm going to do the same thing. I'll plug into the Pythagorean theorem. and I will get 2 squared plus 3 squared equals 4 squared. 2 squared is 4, 3 squared is 9, 4 squared is 16, 9 plus 4 is 12, and 12 does not equal 16. So this set of numbers does not satisfy the Pythagorean theorem, so that means this set of numbers could not represent the lengths of the sides of a right triangle. Number 17, how many points are 5 units from a line and also equidistant from 2 points on the line? So this is just your basic locus question, right? So let's take a look at the first criteria. So it says 5 units from a line. So you're going to start off with a line, okay, just an arbitrary line. I decided to draw it horizontally, but you can also draw it vertically, right? Just going to draw one line first. Now, how can I represent all the points that are 5 units from this line? Well, that could be represented with 2 lines, one above and one below. And then every point on these 2 lines is 5 units from the line, correct? So I'm assuming, of course, I'm assuming that from here to here is 5 units, and from here to here is 5 units. But these 2 dotted lines do a good job of showing me all of the points that are 5 units from that line I started off with. But then it also says, and also equidistant from 2 points on the line. So equidistant from 2 points on the line. Now when it says on the line, it's talking about the original line. So I'm just going to draw 2 arbitrary points on the line. I'll draw one here and I'll draw one here. It doesn't matter where you draw them on the line, as long as you draw them on the line and then there's some separation between them. So how can I represent all the points that are equidistant from these 2 lines? Well, I can represent them by drawing a line like this right through the middle. Any point on this line that I just drew is equidistant from those 2 points. And what does that mean? That if I were to draw a point anywhere on this line, I would be the same distance away from those 2 blue points. So now go back to the question. How many points are 5 units from a line and also equidistant from 2 points on the line? Well, that would be 2 points. That would be this point here and this point here. Only at these 2 points, the red points, only at these 2 points are you 5 units from the original line and equidistant from the 2 points that are on that line. So the answer to number 17 is choice 2. Number 18 says the equation of a circle is x minus 2 squared plus y plus 5 squared equals 32. What are the coordinates of the center of this circle and the length of its radius? So if you'll recall, the standard equation for a circle is x minus h squared plus y minus k squared equals r squared. So to get h and k, that means to get the center, you have to take these guys over here and change the signs. So the center of the circle is actually 2, -5. That's the center. To get the radius, you got to take this guy over here, that 32, and you have to square root it, because that 32 is the radius squared. So to get the radius, you got to undo that squaring. So that means that we have to square root it. So we got to square root radical 32. So when we square root radical 32, of course, we get a decimal. They don't want a decimal answer. They want it in simplest radical form. So you will simplify radical 32, which can be simplified with radical 16 times radical 2, and so we get 4 radical 2 for the radius. So the answer is choice 4. Number 19 says the equation of a line is y equals 2/3 x plus 5. What is an equation of the line that is perpendicular to the given line and passes through the point 4, 2? So I like to say that with these questions, there are 3 steps. So I'm just going to write step 1, step 2, and step 3. So there's 3 steps to these questions. That says step 2. I know my handwriting is sloppy. My apologies. All right, so the first step is to get the slope of the perpendicular line. We know the slope of the original line is 2/3. So that means the slope of the perpendicular line has to be the negative reciprocal of 2/3. So the slope of the perpendicular line is -3/2. That's the first step, right? Get the slope of the perpendicular line, and you can get that by taking the slope of the given line, flipping it, and changing the sign. The second step is to solve for the y-intercept of the perpendicular line that we're looking for. And the way we do that is we do that by substituting into y equals mx plus b. And I'll tell you what we're going to substitute, okay? Of course, we will substitute the m we just got. We will substitute the slope of the perpendicular line, which is -3/2. And we have to substitute for x and y. Now, let me show you where the x and y comes from. The x and y comes from the point that line has to pass through. So that means x equals 4 and y equals 2. This is your x and y. That's where it's coming from. So when you're going to plug into this to solve for b, okay, a lot of people assume that b is 5. No, that's the slope of, excuse me, that's the y-intercept of the original line, but we're looking for another y-intercept. So when we plug in, we're going to get 2 equals -3/2 times 4 plus b. And we're going to go ahead and solve for b. So we get 2 equals 4 times negative. So what you do here is you just multiply these guys and then divide by the denominator. So 4 times -3 is -12. -12 divided by 2 is -6. So we get -6 plus b. Add 6 to both sides, and we get 8 equals b. The last step is we're going to write the new equation. So we take that m, that's that slope of the perpendicular line, and that b, the new b, and we write an equation with it. And we get y equals -3/2x plus 8. So the answer is choice 4. Number 20 says, consider the relationship between the 2 statements below. So the first statement says, if the square root of 16 plus 9 does not equal 4 plus 3, then 5 does not equal 4 plus 3. The second statement says, if the square root of 16 plus 9 equals 4 plus 3, then 5 equals 4 plus 3. These statements are. Now look, you know, some students are going to try to understand what this is saying, and that's fine. If you want to try and understand that, that's great. But what you really need to focus on for this question, what they really want you to focus on, is this over here, right? In the first statement, it says does not equal for the hypothesis and the conclusion. And in the second statement, it says equals. So first statement says does not equal. In the second statement, that is negated. Now, if you're only negating the hypothesis and the conclusion, then that's called, you're taking the inverse of the original statement. So these statements are inverses. Let me tell you why they're not converses. They're not converses because in a converse, you would just switch the hypothesis and the conclusion. So So if this is the original statement, I'm not going to read it again, but if, so if this is the original statement, what the converse would say, if 5 does not equal 4 plus 3, then the square root of 16 plus 9 does not equal 4 plus 3. You see what I'm saying? The converse would just switch it. The contrapositive would switch it like the converse, but it would also negate. And then a biconditional has a if and only if part in the middle of the statement. So the answer to 20 is choice 1. So number 21 says, in the diagram of trapezoid ABCD below, AB is parallel to DC, AD is congruent to BC. So let me go ahead and label that. The measure of angle A is 4x plus 20, and the measure of angle C is 3x minus 15. What is the measure of angle D? Okay, now, since this is an isosceles trapezoid, one of the properties of isosceles trapezoids is that the base angles are congruent. So this is 3x minus 15. This is also 3x minus 15. Let's look at the top base. 4x plus 20 is one of the angles. The other angle is also 4x plus 20. Now, four-sided figure. Figure's got 4 sides, right? It's a polygon with 4 sides. What must all the angles add up to? Well, in a 4-sided figure, the angles add up to 360. So angle A plus angle B plus angle C plus angle D equals 360. So let's add it all up, set it equal to 360, and that's how we will get the value of x. When you add up all the angles, we get 14x plus 20 plus 20 is 40, and then that's going to be negative 30. 40 minus 30 is 10. So we get 14x plus 10 equals 360. And we're going to go ahead and solve for x. Subtract 10 on both sides. We get 14x equals 350. Divide both sides by 14. So that's 350 divided by 14. That's 25. So x is 25. Now look, they're sneaky, right? They put 25 as an answer there, but the answer is not 25, okay? Don't fall for that trick. You got to plug in to get angle D. So angle D is expressed as 3x minus 15, so we'll plug in that 25 for x. So that's going to be 3 times 25 minus 15. 3 times 25 is 75. 75 take away 15 is 60. So the answer is choice 3. Number 22. In circle R shown below, diameter DE is perpendicular to chord ST at point L. Which statement is not always true? So let me point something out here before I even look at the choices. Whenever you have a chord that is perpendicular to a radius or to a diameter, automatically this side is equal to this side. And this side is equal to this side. It's just automatic. So let's go through the choices now. And of course, these triangles are congruent to each other by side, 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 or side angle, side, and so on and so forth. Anyways, let's go through the choices. Which statement is not always true? So it says SL is congruent to TL. No, that's true. Just went over that. RS is equal to DR. That's true. That is true. I know I didn't cover that, but that is true. Let me explain why that's true. RS is a radius. Let me write that down. RS is a radius. You notice something else? DR is also a radius. So DR is a radius as well. Remember, a radius is a line that connects the center of the circle to a point on the circle. So that is true, right? They are both radii, and so the radii are congruent, so choice 2 is true. RL is congruent to LE. That is not true. So the answer is choice 3. And then choice 4 has a proportion of, what's it got? DL times LE is equal to SL times LT. This is true. You know what this is going over? This is looking at that formula. Segment piece, I've covered this in my class this way. Segment piece times segment piece equals segment piece times segment piece. That's what this is. This is substituting into that formula, and that's true. So the answer is 3. That's the one that's not true. Number 23. Which equation represents circle A shown in the diagram below? Well, if we zoom in to the center of this, you will see very clearly that the center of the circle is -4, comma, -1. That's the center of the circle. That says -4, -1. It's a little sloppy. I'm going to write that again. Okay, my bad. -4, comma, -1. Okay, now the radius, so to get the radius, you just have to count from the center to a point on the circle, and when you count, it comes out that the radius is equal to 3. So we will plug this in. So let's zoom out, and we're going to plug this in to our circle formula. The h and k comes, of course, from the coordinates of the center. So we will get x minus -4 squared plus y minus -1 squared equals 3 squared. You're going to simplify these signs. You get x plus 4 squared plus y plus 1 squared equals 9. And the answer is choice 4. Number 24. Which equation represents a line that is parallel to the line whose equation is 3x minus 2y equals 7? Well, parallel lines have the same slope. So we got to find the slope of this given line. And a line that is parallel to it will have the same slope as that line, whatever it is. Let's go ahead and find it. To do that, we got to put it in standard form. So we got 3x minus 2y equals 7. We're going to subtract 3x from both sides. We will get -2y equals -3x plus 7. We'll divide everything by -2. This cancels out. We get y equals positive 3 over 2, x minus 7 over 2. Now, why did I say positive? Because a negative over a negative cancels out. And then I just left this in fraction form. Okay, now, the whole point of doing that was to identify the slope. The slope is 3 over 2. So a line that's parallel has to have that same slope. So that would be choice 3. Number 25. So it says the measure of arc CD is 70. So this arc here is 70 degrees. The measure of arc AB is 20. That's referring to this arc over here, okay? That arc is 20. What is the degree measure of angle P? So they want angle P. All right, let's zoom out. Now, to find angle P, we got to use the formula. The major arc, or the major intercepting arc, subtract the minor intercepting arc, and then the result of that divided by 2. That's the formula. That's how you're going to get angle P. Memorize that formula. When you're looking for an angle outside of the circle, you got to use this formula, right? So angles outside the circle, the context of the problem is to use this formula. So we'll plug in. We get 70 minus 20 over 2. 70 minus 20 is 50. 50 divided by 2 is 25. So the answer is choice 1. All right, number 26 says, the measure of an interior angle of a regular polygon is 120 degrees. How many sides does the polygon have? All right, so in this polygon, which is regular, that means all the angles are the same, the interior angle measures 120 degrees, which means that the exterior angle measures 60 degrees. Now, how did I get that? I just did 180, take away 120, and I got 60 degrees. All right, now, the sum of the exterior angles for any polygon, so the sum of exterior angles, I'll just say sum of exteriors for any polygon is 360. For this polygon, one of them measures 60. So if I want to know how many sides this polygon has, what I have to do is take 360 and divide it by 60. And when I do that, I get 6. So the answer is choice 2. Let me go through that one more time, right? So what I did is I found the measure of one of the exterior angles. One of them measures 60. Now I know that they all have to add up to 360, right? So just do 360 divided by 60 and you'll get the amount of sides that it has. And so the answer is choice 2. All right, number 27 says if AE equals x plus 2 and BD equals 4x minus 16, then the length of AC is. Now, I didn't read the whole thing, but we were told that this is a rectangle. So if AE is x plus 2, automatically EC is x plus 2. And then we are told that the diagonal BD is 4x minus 16. Now here's the deal. In a rectangle, the diagonals are congruent. Now that means that the diagonal AC is congruent to the diagonal BD. This is true for rectangles, and it's also true for squares, just so you know. So I'll get 2x plus 4. Whoa. Where did the 2x plus 4 come from? Well, you got to add x plus 2 and x plus 2, and you'll get the whole diagonal AC. See how I did that? And we're given the whole diagonal BD as 4x minus 16. So let's go ahead and solve for x. Try to do this the quickest way. So let's add 16 to both sides and subtract 2x from both sides. So this guy cancels out, this guy cancels out, so we get 20 equals 2x, x equals 10. But be careful, right? The answer is not 10. Got to plug in to find the length of AC. So if you want the length of AC, let's plug in to 2x plus 4, because remember AC equals 2x plus 4. So that's going to be 2 times 10, that's 20. 20 plus 4 is 24. So the answer is choice 4. Okay, number 28 says if the vertices of triangle ABC are A, negative 2, 4, B, negative 2, 8, and C, negative 5, 6, then triangle ABC can be classified as. So I went ahead and plotted the points on a graph. I do it because I believe it helps me. Another approach would be to just simply use the distance formula and find the 3 distances of the triangle, and then based on those distances classify it as either right scalene, isosceles, or equilateral. Okay, so this is the method I chose to do. Just because I'm a more visual person, I can see from here that the length of AB is 4 units, counted from 4 to 8, 4 units. Now, to get the length of CB, I can go ahead and use the Pythagorean theorem by forming a right triangle here. And then the length of this leg is 3, the length of this leg is 2. So I'll use the Pythagorean theorem to find the hypotenuse CB. You could see that CB is a hypotenuse of this red right triangle I just formed here. So I get 2 squared plus 3 squared equals CB squared. I'll get 4 plus 9. So then I'll get 13 equals CB squared, square root both sides. The length of CB is radical 13. To find the length of AC, do the same thing. Form a right triangle, but you'll see that you get 2 and 3 again. So that means the length of AC, or CA, is also radical 13. So it's not equilateral, because in an equilateral, all sides are equal. We only got 2 equal sides, so it's isosceles. All right, number 29. So number 29 says, after the transformation, reflection across the line y equals x, so this is a reflection being performed. The image of triangle ABC is triangle A prime, B prime, C prime. If AB equals 2x plus 13 and A prime, B prime equals 9x minus 8, find the value of x. So what they're really testing here in number 29 is whether or not you understand that in a reflection, the distances of the original figure are preserved. So remember, right, if you reflect an object across a line or across a point, the image that's produced is congruent to the original image. So we know that AB is equal to A prime, B prime. So you got to set these guys equal to each other. So you get 2x plus 13 equals 9x minus 8. We're going to go ahead and solve for x. Subtract 2x on both sides. Add 8 to both sides. This cancels out. This cancels out. You get 21 equals 7x. So we know that x equals 3. All right, so number 30 says, in the diagram below, circles A and B are tangent at point C. So that means that these two circles are touching each other at exactly one point. And AB is drawn. Sketch all common tangent lines. So the circles here are tangent to each other, right? You will be able to draw 3 tangent lines. Now there are different scenarios that you might encounter on a Regents with this type of problem. Now let me show you all the different scenarios that you might encounter. You might get 2 circles that are separated, and in that case you will get 4 common tangents, like what you see here. If the circles are tangent to each other, like how we have in the problem we're currently doing, you'll get 3 common tangents, like you see here. This is if the circles are overlapping. This is if the circles are, so if you have one circle inside the other circle so that they are still tangent to each other, you'll get 1 common tangent. And then this is if you have concentric circles or one circle floating inside the other circle, you'll get no tangent. So these are the different scenarios you might face. The scenario we're facing is this one, where the circles are tangent to each other. So in that case, you know you're supposed to get 3 common tangents. So to draw your tangent lines, take your ruler, put it up against the circles so that the ruler is tangent to both of these circles. And then hold the ruler there, take your pen, and draw yourself a common tangent line. And then let's go ahead and do the same thing on the other side against the circles, and draw yourself the common tangent. Do the best that you can. I'm struggling a little bit here. All right, there's the second one, and then you got to get a tangent right in between the circles. Remember that? Should be like a perpendicular. It should be a perpendicular line. So perpendicular to AB. So we get our 3 common tangents. All right, number 31. On the set of axes below, graph the locus of points 4 units from 0, 1. So I'm going to stop there. I'm going to do that part first before I even continue reading. So 4 units from 0, 1. Locus of points 4 units from 0, 1. In other words, draw for me all of the points, or represent all of the points that are 4 units from 0, 1. So where is 0, 1? 0, 1 is here. Now I want to draw all the points that are 4 units away from there. So to do that, if you forgot you're supposed to get a circle, what you could do is start with 1 point 4 units away from there. So let's go ahead and do that. So here's the point 0, 1. 4 units away from there, you'd get a point 1, 2, 3, 4 here. But then you'd also get a point 1, 2, 3, 4 here. 1, 2, 3, 4 here. 1, 2, 3, 4 here. So you see what I did there? I already know you're supposed to get a circle because I'm so used to doing these so many times. But if you forget, just start with 1 point. Right? And then another, and then another, and then another, until you realize that what you're just supposed to draw here is a circle. Why? Why a circle? Because this circle represents all the points 4 units away from 0, 1. All right? So this circle represents all the points 4 units away from 0, 1. All right, let's move on to the second part because there's a second locus. It says, and the locus points 3 units from the origin. Now, where is the origin? The origin is right here. It's 0, 0. So all the points 3 units from the origin. So in case you forgot, the origin is 0, 0. All right, start with 1 point 3 units away from here. 1, 2, 3, right there. Start with another, not start, but do another one 3 units away from the origin. 1, 2, 3, right there. And another one, 1, 2, 3. And another one, 1, 2, 3. And you'll realize, oh, wait a minute, you know, a circle will represent all the points that are 3 units away from the origin, a circle with a radius of 3. So let's go ahead and do that. And you get a circle like this. All right, so you got a circle with a radius of 3. Let me just go ahead and make that circle dotted. All right, now, it says label with an X any points that satisfy both conditions. So in other words, label with an X the points that are 4 units from 0, 1 and 3 units from the origin. Well, there's only 1 point that does that, and that's this point here, right? It's 4 units away from 0, 1, and it's also, at the same time, 3 units away from the origin. Number 32. We've already been over the standard equation of a circle. It's x minus h squared plus y minus k squared equals r squared. So h and k is the x and y coordinate of the center, and then the radius is 5 because the diameter is 10, so they kind of try to get you there with that. So what we'll do is we'll now plug into the formula, so we will get x minus negative 3 squared, because you got a subtraction sign and a negative sign there. I'll simplify in a bit. I just want to make sure I go step by step. So then we get y minus 2 squared equals 5 squared. So now when I say simplify, what I really mean is just, you know, simplify these signs so and square the radius. So we will get x plus 3 squared, right? Because subtracting a negative is really just adding, positive number. So then we will get x plus 3 squared plus y minus 2 squared equals 25 as our final answer. But I believe you could have left it like this and you still would have gotten full credit, because it says write an equation, and technically that is an equation of the circle. Number 33, using a compass and a straight edge, construct a line perpendicular to line L through point P. So we got ourselves a nice construction. It's a perpendicular line through a point. So let's begin. So what you want to do is put the compass on point P, and what we want to do is we want to swing an arc that will intersect that line at 2 points. So this arc is going to be nice. So I'm going to go ahead and do that. So let's swing it. See how the arc intersects 2 points on that line, right there and right there. All right, keep your compass setting the same. Don't change the compass setting. Put it on one of the points of intersection, and swing an arc as well. Keep the compass setting the same throughout this whole construction. Put it on the other point of intersection. Swing an arc. And then you'll get a new point of intersection right over here. You see it? What you want to do is you want to connect that point of intersection to point P, and that's your perpendicular line through point P. All right, there it is, perpendicular line through a point. Number 34 says write an equation of the line that is the perpendicular bisector of the line segment having endpoints 3, -1 and 3, 5. The use of the grid below is optional. So I'm actually going to go ahead and use the grid, and I actually went ahead and plotted the points. As you can see, what they want is the equation of the line that's the perpendicular bisector of the line segment that contains or that has these 2 points. So why don't I go ahead and just draw that perpendicular bisector for you so you can see it. So the perpendicular bisector has to be, of course, perpendicular. All right, and it has to go through the midpoint of that line segment. So the midpoint was right there. So this is the perpendicular bisector, that dotted line. What's the equation of that dotted line? Well, it's y equals 2. There you go. That's the answer. This one was pretty straightforward. Sometimes you don't get that lucky. All right, number 35 says a right circular cylinder with a height of 5 centimeters. So it's got a height of 5 centimeters with a diameter of 6 centimeters. So that means it's got a radius of 3 centimeters. Find the lateral area of the cylinder to the nearest hundredth of a square centimeter. The reason why it says square centimeter is because you're looking for an area. So you'll have to use the formula. Lucky for you, you don't have to memorize it. It's given to you in the Regents reference sheet. Let's go to the reference sheet. So the lateral area of a right circular cylinder, you can see it right there. It's L equals 2 pi RH. So let's write it. L equals 2 pi RH. And let's go ahead and substitute into the formula and we'll get our answer. So we're going to get 2 pi times 3 times 5. And then that's just going to be 2 times 3 times 5. 2 times 3 is 6. 6 times 5 is 30. That's going to be 30 pi. But they don't want the answer in terms of pi. They want the answer to the nearest hundredth of a square centimeter. So that's just going to be 30 times pi, which is going to be 30 times 3.141592, blah, 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 blah. We get approximately, shouldn't write equals, should write, we get approximately 94.24776, but we're going to round it to the nearest hundredth. So the hundredths place is right here. So that means we'll look at the number to the right of that, and if it's 5 or higher, that number that I underline is gonna go up. So we will get 94.25 as our final answer for the lateral area. I guess units, you should worry about the units, right? The units would be centimeters squared, but you don't have to put them for this Regents, but it is centimeters squared. All right, then it says find the volume of the cylinder to the nearest hundredth of a cubic centimeter. So to find the volume, the formula is pi r squared times the height. Now, if you actually look at the formula sheet, it's actually given as V equals capital B times H. Now, let me explain how I go from this to this. That capital B stands for area of the base. If you actually look at a cylinder, okay, looks like this. I mean, sort of looks like this, right? I'm not the best artist. You'll see that the base is a circle, and the area of a circle is pi r squared. So I got rid of the B and put in pi r squared. This is the formula you're supposed to use. They don't give it to you like that on the Regents, because they're assuming that you're supposed to know that the area of a circle is pi r squared, but this is what you must use. So we'll get pi times 3 squared times the height. So that's going to be 9 times 5, which is 45, so we get 45 pi, but they want you to round it to the nearest hundredth, so that's going to be 45 times pi. All right, 45 times pi gives you approximately 141.37164. You're gonna have to round this to the nearest, what's it say, 100? So you get 141.37. Okay, number 36 says triangle ABC has vertices A 5, 1, B 1, 4, and C 1, 1. State and label the coordinates of the vertices of triangle A double prime, B double prime, C double prime, the image of triangle ABC following the composite transformation, translation 1, -1, after dilation of 2. Now, the important thing that you really want to remember for these is that you start with the rightmost transformation. So with these compositions, you always start with the one on the right. So the original coordinates, they're given as these guys over here, right? So first, you're going to perform the dilation. So dilation means that you're just going to multiply each of the coordinates by that scale factor. In this case, the scale factor is 2. Right? So just multiply each of the coordinates by 2 times 2 times 2 times 2 times 2 times 2 times 2, and you get these coordinates. Next, you're going to perform the translation to these new coordinates. So performing that translation means that you're going to add 1 to each of the x coordinates, and you're going to subtract 1 from each of the y coordinates. After you do that, you will get these coordinates. All right, so then the final answer is this. Okay, next problem. We've got number 37. In triangle ABC, angle A is x squared plus 12, angle B is 11x plus 15, and angle C is 13x minus 17. Determine the longest side of triangle ABC. We're going to have to solve for x first. So we know that in a triangle, the 3 angles must add up to 180. So we'll get x squared plus 12 plus 11x plus 5 plus 13x minus 17 equals 180. When we combine like terms, we'll get x squared plus 11x plus 13x. That's going to be 24x. So then we got 12 plus 5 is 17 minus 17. They're going to cancel out. So we get x squared plus 24x equals 180. It's a quadratic, so we got to set it equal to 0. And we will get x squared plus 24x minus 180 equals 0. Right? Because I subtracted 180 from both sides to set it equal to 0, because that's what you're supposed to do when you're trying to solve a quadratic. You want to set it equal to 0. Next step is to factor. So we get x and x here. Now here, what you want to do is you want to find two numbers that multiply to give you negative 180 and at the same time add up to give you positive 24. Now those two numbers are 30 and 6. And to be more clear, it's actually positive 30 and negative 6. Now think about it for a second, right? 30 times negative 6 is negative 180, right? Since this is a negative number, one of them has to be negative. But we made the smaller one negative because these two numbers have to add up to positive 24, and 30 plus negative 6 is positive 24. And then the next step is to take each one of these binomials and set them equal to 0, and then just solve them like they are regular linear equations. So we get x equals negative 30, and then add 6 to both sides here. We get x equals 6. So x equals 6. We're going to reject the negative answer because it will produce a negative angle, which is not possible. So it gets rejected. So the answer, not the answer, excuse me, the value of x that we're going to use is x equals 6. All right, we're still not done. This is I know this is a little bit of a long one. If you draw the triangle, by the way, this triangle is not drawn to scale. I'm just going to draw an arbitrary triangle and then just call it triangle ABC. If you draw the triangle and label the vertices and then label the angles, you'll get something like this or something close to it. Angle A will measure, so we'll get 6 squared plus 12. That's going to be 36 plus 12. 36 plus 12 is going to give you 48. So angle A is 48 degrees. Angle B, we're going to get 66 plus 5. That's going to be 71. And then angle C is going to be 13 times 6. Take away 17. 13 times 6 is 78. Take away 17, we get 61. So angle C is 61. Check them, make sure they add up to 180. So we get 61 plus 71 plus 48. They add up to 180, all right. All right, now, the whole point of this is so you could determine the longest side of triangle ABC. The longest side is AC, and I'm going to tell you why. Because it's across from the largest angle. So AC is the longest side. AC is the longest side. And the reason is because it's across from the largest angle. They didn't say to justify your answer, so that's why I just wrote AC is the longest side. But if they did ask for a justification, you would say AC is the longest side because it's across from the largest angle. Okay, so number 38, it is a proof, and we are told that this angle here, angle ADG, is congruent to this angle here, angle BCG. So we know those two angles are congruent. We're trying to prove that segment AE is congruent to segment BF. All right, so let me just take you through how I think these through, because I know that these are a little confusing for some students. So here's how I go about it, all right? I know that I'm trying to prove AE congruent to BF. Those are parts. So somewhere along the line, there's going to be a CPCTC, okay? So that's the first thing that pops into my head. I know I'm going to see a CPCTC in there somewhere. All right, so now, the thing I want you to see is I want you to see that the segment AE is a part of the line segment AF. And the segment BF is a part of the line segment EB. So now why do I say that? I say that to say that somewhere down the road you're going to see a line proof. Okay, you're going to see a line proof somewhere down the road. Now, with that being said, okay, let's focus on AF now. AF is a part of this triangle here. And EB is a part of this triangle here. So what's the point of saying all that? Well, the point of saying all that is to say that I want to prove these two triangles congruent using one of the postulates, right? Then after I prove those two triangles congruent, I can use CPCTC to say that AF is congruent to EB, and I'm going to need that for my line proof. Now, I know that's a little confusing. There was a lot there. So let me just take you through it. All right, so let's begin. So I started the proof by putting the given down. So that's my first statement. My next statement is I said that AD is congruent to BC. So I said AD is congruent to BC, and it's because opposite sides of a rectangle are congruent. Now, the reason why I'm doing that, why am I going that route? Why is that the route I'm going? The reason I'm going that route is because I'm trying to prove first I'm trying to prove that this triangle here, all right, that triangle that I highlighted in yellow, I'm trying to prove it's congruent to this triangle here. So that's why I'm going this route. All right, I'm trying to prove those two triangles are congruent. So far I got an angle congruent to an angle, a side congruent to a side. Let's keep going. I know that angle A is also congruent to angle B, and the reason why I know that is because these two angles are 90 degrees, because remember, this was a rectangle. So, in a rectangle, the angles are 90 degrees, and all 90-degree angles are congruent. So I know A is congruent to angle B. Okay, so then once I've done that, I can go on to say that the triangles are congruent by angle, side, angle. So it's angle, side, angle, congruent to angle, side, angle. Okay, all right, let's keep going. Now, the whole point of that, the reason why I did that is because I want to say that AF is congruent to EB. So I wanted to say AF is congruent to EB by CPCTC, right? So CPCTC always comes after you prove the triangle is congruent. Now, why is that the route I'm going? The reason why I'm going that route is because AE and BF, they're both pieces of the segment AEFB. Here's what I mean, right? This is basically a line proof, right? That's what this is. It's coming down to a line proof or a segment proof, maybe your teacher called it. So you got A, E, and then you got FB. So I'm trying to bring it down to that line. So that's why I ended up saying here that AF is congruent to FB, because I'm going that line proof route. I am in the process of making line proof videos, but if you just search for line proof videos, you can definitely find some help with that in that area. But that's the route I'm trying to go here. So that's why I said AF is congruent to EB. Now, it's just a line proof from this point forward. So I'm going to go partition postulate now. I'm going to say that AE plus EF is equal to the whole segment AF. And I'm also going to say BF plus EF is equal to the whole segment BE. That makes sense, doesn't it? Here's what I'm saying, right? I'm saying this segment AE, right? So let's give it a number. Let's say AE measures 1. Let's say EF measures 2, right? What would the whole segment AF measure? Well, it would measure 3, right? You have to add those two parts, right? The part plus the part gives you the whole. That's what I'm doing here, right? I'm saying the part AE plus the part EF equals the whole thing AF. And same thing with the second part here. I got BF plus EF equals the whole thing. So let's say BF is 1 and EF is 2, then what is the whole thing EB equal? Well, it would equal 3, right? You got to add the two parts to get the whole. So that's what I got there. That's the partition postulate. Okay, now check this out, right? I know from this statement here that AF is equal to BE. I know these two are equal. So if these two are equal, I can say these two are equal by substitution. See what I'm saying? Does that kind of make sense? So I'm just going to use a substitution postulate to say AE plus EF equals BF plus EF. And then what I'm going to do next, I can subtract EF from both sides because it's the same quantity, right? So I'm saying let's subtract EF from both sides. That's the subtraction postulate. So these two will cancel out, and what will I be left with? I'll be left with AE is congruent to FB or BF by the subtraction postulate. So that's the proof. That's how I did it. Look, the key to this proof, right, is realizing that it would eventually lead to a line proof. And I think maybe that's the most difficult part for people. I would just really look up videos that go over line proofs. Like I said, I'm in the process of making one. I covered these in my class early on. But I don't have any videos out now, but look them up. I'm sure there's plenty out there. Just YouTube line proof or Google line proof, and you'll find videos along those lines. So the key is, realizing that it was going to lead to a line proof, realizing that you would have to prove those two triangles are congruent, and then use CP/CTC. Okay, I hope this video helps. Take care.